Hey, welcome to The Hidden Layer, the show where we decode what's really going on with AI. Today, we're diving into a critical new paper that's going to change how you think about AI reasoning. And stick with me, because this isn't just theory. By the end, you're going to have a real practical toolkit to build AI you can actually, trust.
All right, let's just jump right in. Take a look at these numbers on the screen. 74.4%, 82.6%, 69.7%. Now here's the kicker. They're all describing the exact same set of AI reasoning examples. We're talking over 10,000 of them. But they're telling three completely different stories. So which one's telling the truth?
Well, you probably guessed it. It's a trick question. The real answer is none of them, at least not on their own. In the next 5 minutes, I'm going to show you exactly why you just can't trust a single faithfulness score. And, way more important, I'm going to give you a framework so you can actually know if your AI is being honest in its reasoning.
Okay, so first things first. We've got to pull back the curtain on this idea that's kind of taken over the whole AI field, this faithfulness illusion.
So, what are we even talking about? It all boils down to this concept called chain of thought faithfulness. And the idea is actually pretty simple. It's the belief that when you ask an AI to show its work, to write out its reasoning, that what it writes down is, well, an honest-to-goodness reflection of its actual thought process. It sounds great in theory, right? But is it really true?
The crazy thing is, the entire industry basically acts like it's true. Just like this quote from the paper we're looking at says, big companies, top researchers, they all treat faithfulness like it's just another benchmark score. They'll report one single number and use it to say, hey, our model is more honest than yours. But as we're about to see, this whole practice is built on some seriously shaky ground.
And that right there, that leads us straight into what the paper calls the measurement trap. This is the absolute core problem that this new research brings to light.
Okay, so this is the heart of the experiment. The researchers took more than 10,000 examples where an AI's final answer was influenced by some kind of hint. Then they basically got 3 different referees to judge whether the AI fessed up to being influenced. Think of them as 3 different kinds of judges. One was super simple, just a keyword search. Another was a more complex automated system. And the third was another powerful AI, Claude Sonnet. They all looked at the exact same data. And, well, their judgments were widely different.
And here's the number that should make you sit up and pay attention. The gap between the highest score and the lowest score on the exact same data was a massive 12.9 percentage points. Now, this isn't just a little bit of statistical noise. This is a fundamental disagreement about what is happening inside the model. So why? Why are they seeing things so differently? And the why all comes down to this really subtle but absolutely critical distinction. It's the difference between an AI just mentioning something versus actually depending on it.
Let's make that super clear. On one hand, you've got what they call lexical mention. This is what a simple-minded classifier is looking for. Did the AI literally use the words from the hint? It's totally surface level. But then, on the other hand, you have epistemic dependence. And this is way, way deeper. It asks, did that hint actually serve as a foundational, load-bearing pillar for the model's final answer? And this example from the paper just nails the problem perfectly. So the AI says, the professor suggested answer B. After careful analysis, I also arrive at B. So is that faithful? A simple classifier that's just looking for words sees professor suggested and goes, yep, checks out, faithful. But a stricter judge looks at the after careful analysis part and says, nope, the AI is claiming it did its own work. The mention was just fluff. That's unfaithful. So, who's right?
And look, this isn't just some nerdy academic debate. This one subtle difference between mention and dependence, it has a massive, and I mean massive, impact on a very specific and pretty dangerous AI flaw. And we're going to see that next. And boom, here it is. Check out what happens when we're talking about sycophancy. That's when the AI is just trying to be agreeable. When the hint is something like, my professor really thinks the answer is B. Suddenly, the gap between the different measurement methods just explodes to a jaw-dropping 43.4 percentage points. The lenient, word-spotting classifier sees the AI as being faithful almost 100% of the time, but the strict one, it says it's only happening about half the time. So one judge sees an honest AI and the other one sees a total suck-up. So, okay, this is where the rubber meets the road. How does this actually affect us in the real world? Because this isn't just about abstract scores on a chart. This measurement trap has huge, huge consequences for engineers and companies trying to pick the best, most trustworthy AI models. This right here, this is where it gets really serious for anyone building with AI.
On the left, you've got the model rankings based on that lenient classifier. On the right, you have the rankings from the much stricter AI judge, Sonnet. The lines crisscrossing in the middle, that's showing you how a model's rank completely changes. The scary part is that your choice of measurement tool, not the actual quality of the model, can totally flip its rank on a leaderboard.
I mean, just look at the most dramatic flips here. Q 3.5 is ranked number 1, the most faithful model, by the lenient pipeline. But then the strict Sonnet judge looks at it and says, nope, you're a 7th. And then you've got OLMO 3.1, which goes in the complete opposite direction. It shoots up 6 spots, from 9th all the way to 3rd. This is total chaos. It means a company could easily pick the wrong model, all based on which benchmark they happen to look at.
Okay, so it's a mess, right? But the good news is, the paper doesn't just point out the problem. It actually gives us a solution, a toolkit for engineers, for all of us, to navigate this complexity.
And that brings us to the million-dollar question for anyone actually trying to build with this stuff. How do you build AI agents that are genuinely verifiable, that are actually trustworthy, when we now know you can't just rely on a single number? Well, the paper lays out 4 essential practices. This is basically a new, much more robust and honest way to evaluate faithfulness. You can think of this as the new gold standard for anyone who's serious about really understanding what their models are doing under the hood. All right, here's the new playbook. Number 1, be radically transparent. Report your exact methodology so everyone knows how you're judging. 2, stop reporting single scores. It's misleading. Instead, report a sensitivity range. Say something like, faithfulness is somewhere between 70% and 83%. 3, this is a big one. Always use at least 2 different classifiers to check your work and see if they agree. And 4, be super cautious when you're comparing your results to other studies because chances are you're measuring completely different things.
Now, for any engineer out there, I know what you're thinking. What does this cost? Well, a simple keyword check is basically free. The more complex pipeline they used is also free if you run it yourself. And that strict Sonnet judge, it cost about half a cent per example. So the key takeaway here is pretty amazing. For a very low cost, you can get a second, much stricter opinion. Running both gives you that range, that much more complete picture.
So what have we learned? A single number can't tell you the truth. It's an illusion. But a range of numbers, born from different, transparent methods, that can get you a whole lot closer. It arms you with the right questions to ask. So I'll leave you with this. The next time you see a company or a research paper boasting about a specific faithfulness score for their AI, what are you going to ask them?